Hi campers, today we're going to be talking about energy and the transference of kinetic to potential energy and using that knowledge to build a catapult. So I'm sure that you've heard of the energy that powers your house and runs your electricity, your lights, your water, etc. But energy is actually all around us in the world. Even right now, you're filled with energy and I'm filled with energy too. And even food is considered to be energy. So today we're actually going to be talking about two different types of energy, kinetic energy and potential energy. So kinetic energy is the energy that an object has due to any sort of motion. So if you walk or run, you have kinetic energy, and really anything that moves has kinetic energy when it moves, like a car. And the amount of kinetic energy that an object has depends on how fast it's moving. So today we're actually going to be talking about two different types of energy, kinetic energy and potential energy, and we're going to be talking about them in their mechanical forms, meaning that we're talking about these forms of energy in terms that you can see them in your everyday life. So kinetic energy is energy that something has due to any sort of motion. So if you get up and walk around the room or run around the room, you have kinetic energy. And really any object that has movement has kinetic energy, like a moving car, a moving bike, etc. And the amount of chemical energy that an object has is determined by how fast it's moving, or the velocity of the object. There are actually many different types of kinetic energy, including electrical and thermal, and these types of kinetic energy are so small that you can't even see them, like the electrons traveling through your wires in your house to get to the lights above you in the ceiling. Now, potential energy is something that you can sort of think of as the opposite of kinetic energy. It's the stored energy that an object has because of its position or state. So, if you hold an object like this pen up above the ground, it has potential energy because as soon as you drop it, it starts to move and has kinetic energy. And you'd really be surprised at how many objects around you have potential energy. A bicycle on the top of a hill has potential energy because once you start going down that hill, the gravity starts to pull you and make you go faster, and it accelerates your bike down the hill. An object at the edge of your desk also has potential energy because as soon as it tips over, it falls to the ground because gravity is pulling it, and this gravity accelerates it, causing it to have kinetic energy. Compressed or stretched spring is also a great example of potential energy because as soon as you let it go, it springs back to its normal size, and that is a release of kinetic energy that happens there. A rubber band is actually very similar to a spring, and if you stretch it out, it has a lot of potential energy because it's not in its natural state and it really wants to go back to it. So if you let go of it, there's a transfer from potential to kinetic energy because your rubber band is going back to its original state and accelerating to do so. Building off of our knowledge of potential energy, kinetic energy, how potential energy is transferred to kinetic energy, and how that happens within a rubber band, we're going to be making a catapult today. So what you'll need is one tissue box, 3 or 4 rubber bands, and 2 pencils. If you're participating in the Zoom later today, all you need is these materials, and you can pause the video here and come join us later today. You'll also be needing some sort of bottle cap for today's Zoom session, like a milk bottle cap or a juice bottle cap. So, like I said, you'll be needing a tissue box for your catapult, and you'll also need some scissors because what we're going to do is we're going to cut around the top of the box so that we have a big open space to work with. Now, like I said, you'll be needing a tissue box, and then you'll also be needing some scissors so that you can cut around the top of your box and have a big open space to work with. Okay, now that we have cut an open hole in the top of our tissue box, what we're going to do is we're actually going to make 3 different holes in our tissue box. Now, if you happen to have a hole puncher, it'll be super helpful, but if you don't, that's okay, because I don't either. And I'm just going to use my scissors to poke my holes in my box, sort of like we did yesterday with the wheel and axle and the lever that we made. So the first hole that you're going to poke in your box should be about 1 inch down from the top of the box and 1/2 inch away from the side of the box. Now, once you have this hole poked in the box, you'll want to poke one on the exact opposite side in about the same place. So 1 inch down from the top and 1/2 inch away from the edge. Once you have these 2 holes poked, what you're going to do is you're going to take one. Once you have these 2 holes poked, we're going to make our last and final hole, which will be at the opposite end of the box from our 2 holes that we made initially. So my holes are right here, and I'm making my final hole down here. And it will be all the way at the bottom. And this is going to be a really tiny hole, so I wouldn't suggest using a hole puncher for it. So now that you have your 3 holes, what you're going to want to do is take one of your pencils and poke it through the 2 holes at the top. After this, what you're going to do is you're going to take one of your rubber bands and tie it onto the side of the pencil, outside of the box, and this is basically so that the pencil just doesn't slip off. And we're going to do the exact same thing on the other side. Okay, now that you have both of your rubber bands on your pencil, you're going to take another pencil and attach it to the pencil inside of your box using one of your rubber bands. So what I'm going to do is I'm going to take my rubber band, wrap it twice around my pencil, then I'm going to go into the box, and this may be a little bit tricky because you don't have a whole lot of room to work with, but I'm going to wrap around my pencil in the box and then tie it around the bottom of my original pencil. Okay, so once you're done with that, your box should look like this, and your pencil should be hanging out mostly out of the box. Okay, so once you're done with that, your box should look like this, and your pencil should be hanging out mostly out of the box. So the next thing that we're going to do is we're going to take our 4th rubber band, and we're going to put it around our pencil, the top of our pencil, tie it around twice, like so. And then this part is going to be a little bit tricky. We're going to feed it through the hole in the bottom of the box. And once you're all set with your 2 pencils secured, what you're going to do is you're going to take your 4th rubber band and you're going to poke it through the hole in the bottom of the box. And once it's through the hole, you're going to take another pencil and you're going to just stick it through the loop in the rubber band at the bottom of the box. And then you're going to take the rubber band and pull it taut over the pencil at the top of your box and tie it around the pencil around the middle of the pencil. This way you have a lot of room to work with when you actually start shooting your catapult. All right, so now that you have your pencil secured, you'll see that you can pull your pencil back, and then when you release it, it goes back to the front of the box. Now, what we're gonna do is we're going to take our bottle cap and we're just going to tape it to the top of the pencil. And once you're done with that, you have your full catapult, and you can put anything that you want in the cap, like candy, paper clips, anything that's light, and you can launch it with your tissue box catapult. Boom! So let's talk about what's actually happening here. When you pull back your pencil, what you're doing is you're elongating the rubber band, and that's building up a bunch of potential energy. So then when you release it, the rubber band immediately wants to go back to the most compressed state that it can, and the rubber band is still stretched a little bit taut, but it's pulling back the pencil as much as it can, and that's what's making your catapult go forward. Well, thank you guys so much for joining me again today. I really had a fun time building our tissue box catapult, and I hope you come back again later this week. Bye!